continue with the next examples, right? So today I am putting two classes, right? Because I want to wind up this K-map today. Okay, let us continue with the K-map examples. So let us take the next example. Find minimal sum and product expressions for the given function, right? From the given function you can identify this is a 4 variable K-map, 4 variable function, right? So here the method is not given, it is left to you. Best method is K-map, right? So you have to use K-map here. So let us fill the cells, number them if you can't identify numbers cells properly, because before I take the class I do some paperwork, I solve the problems on the paper, then I'll take the class, right? So better you identify the cells than fill up those cells with min terms, right? So try to group these min terms, okay? With you have to cover, please keep it in mind, you have to cover all min terms with minimum number of groupings, right? So how many groups are possible? Before you start grouping, you just identify which all min terms can be put in one group, right? And you can cover all the min terms with minimum number of grouping, right? So let us, by looking at the min terms, I can group these two, because I am covering 4 min terms here. So what is the expression for this? You are covering 4 min terms means you can eliminate 2 variables, that is b bar and c bar, b bar, c bar. Next, you can cover these 4. You can cover these 4 in one grouping. What is the expression for this? It is c d bar. Then the left 4 min terms can be put in one group. So what is the expression for this? It is b and d, right? So if I put plus sign, what I'll get? I'll get the minimal sum term, or you can also call it as minimal sum term, or you can call it as sum of product terms, right? So this is the simplified SOP expression what you can get from the for the given function, right? So just identify, is it possible to group in one more method, right? Is it possible? Just identify. So when I say identify, and you have to pause the video, and identify whether one more method of grouping is possible or not, right? So you have to pause that video, you have to work out, then you continue if you don't get another method of grouping, right? So I can identify one more method of grouping here. So these corner min terms can be put in one group, right? So what is the expression for this? It is b bar and d bar, right? So next, these 4 can be put in one group, right? So what is the expression for this? It is c bar d, b bar, d bar, and these 4 can be put in one group. So what is the expression here for this grouping? It is b and c, right? So you can observe both the expressions are completely different, right? So none of the term is common here, because grouping is also not a common, right, in both the K-maps, right? So either you write this expression and this expression, both are, either you write this expression or this expression, both are correct, okay? So this is the minimal sum terms, either you write this term, this expression, or this expression, both are correct, okay? So next we have to obtain the minimal product term, or I can call it as POS, right? So for POS, the cells which are empty, you have to fill them with what? Zeros, right? Fill them with zeros, right? Then you make zeros grouping, right? So what we call it as max term grouping. 0 0 0 1 1 1 1 0, right? So which are the cells which are left? That is 3 4, then 12, then 11. So these are the 4 cells which are empty, so fill those cells with zeros, right? So here I cannot put all these 4 zeros in one group, right? So what I'll do, I'll go with two zeros grouping, right? So what is the expression for this grouping? Since you are grouping 0, so wherever input is 0, you take its a true form. If it is 1, then you take its a complemented form, right? So when I group these two max terms, so you can observe here, A is 0, A is 1. So both are complement to each other. So A will get eliminated. So but B is 1 here, B is 1. But you are grouping zeros. That means you have to write B in its complemented form, right? So you have to write B bar. Then since C and D both are 0, so and you are grouping 0, C and D both are 0, you write their true form, correct. So when I pause, when I wait, then you have to utter from your mouth also what the next term is, right? Since we are writing a POS term, right? So one term should have only the sum term, right? So that is product of sum. One term should have only sum terms, right? Then dot group these two, right? You can group these two, even though they are not physically adjacent, but they are logically adjacent. So here A is 0, A is 1, complement to each other. So A will not come in the term. So B is 0 here and B is 0, and you are grouping 0 means write B in its true form. Then C and D both are ones, you write them in their complemented form, right? So this is the Boolean expression, what we call it as minimal product expression. So F is equal to, this is nothing but the minimal product or product of some expression. Okay, so I hope these things are getting clear to you, right? Because today I want to wind up this K-map. So I am solving some more examples on K-map, 3 variable, 4 variable, 5 I've already covered. Okay, so I'll solve only 4 variable K-map and 4 variable with don't care terms. Okay, so let us say the next example. So let us draw the 4 variable K-map, because from the given function you can identify there are 4 input variables, right? So draw 4 variable K-map. Zero, because the pi is given here, right? So you have to fill these cells with zeros. The max terms are given. These are not the min terms, the max terms are given, right? So first we will obtain the minimal product term, right? Because I am going to fill these cells with zeros, right? So 0, 1, 2, 3, then 8, 9, 10, 11, 12, 14, right? So I have filled all these max terms with the max term cells with the zeros, right? So let us group. Before you start grouping, keep it in mind, cover all zeros with minimum number of grouping, right? So these two zeros can be combined with these two zeros, and I can put those 4 ones in one group, right? So what is the expression? Directly I'll write the expression only. Since A is 1 here, B1, B0, B is complement to each other, so B will not appear in the term. So A is 1 and you are grouping zeros, that means you have to write A in its complemented form. Then A bar, and here D is 0, so A bar plus D. So this is the first term. Then these two zeros, the corner zeros you can cover, right? Even though these two zeros are already covered, to cover these zeros, right? So I can form this 4 max terms group. So what is the expression? Here it is b plus d, a bar plus d and b plus d. Next, two more zeros are left, right? So these zeros cannot be combined with the other three zeros, and this zero is also cannot be combined with other three zeros. Only 2 zero grouping is possible, right? Group these two zeros, and what is the expression for this? Since you are grouping two max terms, only one variable will get eliminated. What is that variable? Is a. So b plus c plus b plus c. B plus c. Sorry. It is a bar plus b plus c, right? Please correct, right? So then this 0 can be grouped with this 0, can be grouped with this 0. So what is the expression for this grouping? What is the expression for this grouping? It is a plus b plus c bar, right? So this is the final POS expression. This is the final minimal product or POS expression. Next, you have to obtain a minimal sum. Remaining cells in this K-map, the remaining cells are filled with the min terms, right? So wherever you find the empty cells, because there are no don't care terms, so empty cells are to be filled with min terms, right? So just try to group them. How can I group? These 4 can be grouped, right? So these 4 can be grouped. What is the expression? Directly I'll write the expression. For this grouping, what is the expression? It is a bar b. Now you are writing minimal sum or SOP expression. So since you are grouping as ones, wherever 1 is there, you have to write in its input variable ka what? A true form, right? So if you find it 0, you write in its complemented form. Next, plus. These 4 can be grouped, right? So what is the expression for this grouping? You try to group your with your own method before see my steps here, right? So b d, a bar b plus bd. Then these two ones are not physically as well as logically adjacent, or they cannot be combined with 3 more ones. So these ones can be grouped with the remaining the adjacent ones. Only two ones grouping is possible. So what is the expression here? It is a c d, and what is the final one? This one can be grouped with this one. So what is the expression for that grouping? It is a bar, c bar and d, right? So this is the minimal minimal sum term and minimal product term, SOP term. Okay. Next, we'll move to the last example of today's class. So let us fill the cells with max terms, because in the given function the max terms are given. So this is 0, 0. Fill those cells with the max terms and don't care terms, right? So there are 6 max terms and 5 don't care terms. Please identify, number those cells, then you fill the cells. Okay, let us group these cells. So what kind of grouping is possible? These 4 can be grouped, right? So what is the expression? I am writing a minimal product term or POS expression first. So f is equal to a bar plus c, right? Then these corner zeros, 3 zeros can be grouped with this don't care by considering that as don't care as a max term. So what is the expression for this 4? It is b plus d, a bar plus c, b plus d. Then this 0 can be grouped with these 4, this 0. So this 0 can be grouped with this 0 and these two don't care. So what is the expression for this is C plus D bar, right? So this is the expression, right? So just check one more. Can you is it possible to group one more way? Just check. So is there any other way to group these max terms? Let us check. Okay, so if you just verify if you have worked on it. Okay, the first grouping is this four corner grouping. So what is the expression? That second expression will remain same, that is B plus D. B plus D will remain same. B plus D will remain same. Next, this 4. This 0 can be covered with these two don't cares and this 0. So what is the expression for this? It is A bar plus D. Let me verify the previous method. Okay, correct it is. Okay, next, these 4 corner grouping. Next, and these two zeros can be covered with this, right? So what is the expression? It is C plus D bar, right? So two groups are very similar here. This vertical grouping and the corner grouping is same. I have just covered these zeros with logical adjacent groups. Okay, so C plus D bar remains same and B plus D also remains same. Only the variation is there in the last term, that is A bar plus C. Here you will get A bar plus C and here you will get A bar plus D. Both expressions are correct. Either you write the first one or the second one. Now this is minimal product term, or you can call them as POS, right? So let us say the minimal sum term, right? To obtain the minimal SOP expression, so minimal sum expression or SOP expression, put don't cares as it is, right? Except zeros, you put don't care as it is, and the cells which are empty you write ones into those cells. So there are 5 don't cares. I have filled the don't care terms, and the empty cells in this K map, the empty cells are filled with the min terms, that is 1, right? So now try to group. Only one method of grouping is possible. These 3 ones can be covered with that don't care. And what is the expression? It is CD. Expression is CD, and these 3 min terms can be covered with this don't care, and I can put them in one group, right? So what is the expression for this grouping? It is B and C, BC, right? And this one, how will you cover this one? You cannot group, you cannot make a group of 4 min terms, or 2 min terms 2 don't cares, or 3 min terms 1 don't care, or 1 min term with 3 don't care. So this one can be grouped with this one logical adjacent one. Only 2 ones grouping is possible. So what is the expression here? It is A bar, B and D bar. This is the final SOP expression, or minimal sum expression for the given function. I hope all these K-map methods are clear. If you still have any doubts, you can ask me on my personal number, WhatsApp number, or you can put a comment for my video, right? So this completes your the easiest tool to obtain the most simplified Boolean expression, that is kern of map, right? So in tomorrow's class we will discuss one more method to obtain the most simplified Boolean expression, that is called the Queen-McCluskey method. Let us discuss that method in my next example. Thank you.